I want to thank you all for coming out tonight. I'm Steve Flitman, and I'm a neurologist in private practice, and I write code in Perl. And we're going to talk about OCR analysis in a healthcare environment. And I want to thank Ticketmaster for allowing us to meet here. So the interesting question that comes up in a medical practice is how do you handle document workflow? So the biggest issue there is that we have doctors writing orders. So the patient comes to see us and they say they have headaches. So we want to get an MRI scan of their brain. And then we're going to get a report. The report in the ideal world would be somehow emailed to us. And we get an electronic version of the report that would be in text format. It'd be easy to tell by just scanning that document which patient it belongs to, route it to the correct doctor, and you see the doctor's name in the report too, who gets that MRI report, so that it ends up on their practice desktop. So they'll be able to look at it in the electronic health record system. And then if there's something bad on there, and they see a brain tumor, God forbid, something bad like that, they may have to call the patient and say, you gotta come in, we gotta talk about this result. Or they could just send a notice to the medical assistant to call the patient and say, your MRI was fine, and so don't fret about it, and you're gonna come see the doctor in a couple weeks, and we're gonna figure out how to make your headaches better. So that's a common scenario in my practice. And when we started implementing our own health record system, we came up with a huge problem that none of the vendors who handle MRI scans, when they write the reports, none of them have the capacity to email the reports to us. And there's even a problem with emailing it from a legal perspective, which is HIPAA, Health Insurance Portability and Accountability Act. HIPAA makes it illegal for you to send unencrypted documents by email, because email, as we all know, can be eavesdropped. So what is the secure alternative is they can send it by snail mail, so we'd get paper documents mailed to us, but they could have bad news and take a week to get to us from the mail system. That'd be terrible. Or they could fax stuff to us. We have everything faxed over. But that creates the need for optical character recognition, because now we get document images, we don't get text. And so this is all about how I'm using Perl and a lot of software that interfaces with Perl in order to extract that information from those documents. And then it's not enough really to just get OCR, because you'll get text, now you gotta extract meaning from the text. And the text that's produced by OCR is just awful, as I'll show you. We've got some great examples of garbage and gibberish made by OCR. And so that's where Perl really shines in terms of using regular expressions, which of course are extremely important for pattern recognition. So when we have these inputs, all the inputs that you might have test results that come in, like laboratory data, blood tests, imaging, you get x-rays, CAT scan, MRI scan reports. So at this point, we're not talking about the pictures themselves, like a picture of someone's brain. Those pictures, I can get those electronically, and I played with the idea of storing them in the patient records, but I need terabytes. It's crazy how much data they occupy. So a full MRI brain scan could easily be bigger than would fit on a CD, and sometimes bigger than a DVD. And so that's a big problem for trying to store that information. So we just store the reports and then hope that the vendors have enough PACS storage. PACS is their system for storing image data. And they've got huge disk packs, of course. And reports from consultants, too. And then outputs of the practice are going to be encounter notes, things the doctors write about when they saw the patient. That's going to be sent out to the other doctors taking care of the patients. Prescriptions, we'll have to go to pharmacists or pharmacies. We have to fax those out, or we can print them, or we can electronically send those out. And test orders, which have to be made and then faxed out to like an MRI vendor like Simon Med, for example, one of the big vendors. And so it's a complex data environment, and then in the huge push to create workflow which is electronic. The kind of goal will eventually be a paperless office. And one of the tenets of all the big politics in healthcare now, and everything the government's doing with the Affordable Care Act, is of course mandating that more practices convert to electronic workflow. So it's an extremely important area. But what's fascinating is that even with all the mandates and even penalties that you get less money from the government if you're a doctor who doesn't have electronic healthcare system. It's like a 2% penalty now. There's still a huge percentage of practices that are paper only, and they're drowning in paper. And you go in there, and of course you see like 1,000 charts, and your own chart could be like this, not because you're sick, but because of all the paper that comes in, all the faxes from insurance companies and authorizations, and all these documents need to be handled by a competent electronic health record system. And of course, they're coming in analog form if they come in as faxes. So that's where OCR comes in. So we get electronic text, raw data, or image, and then if it's got a star, it needs OCR. Paper, you got to scan that to get it into the electronic health record system. And so the idea is that when paper comes into the practice, we want to get rid of it. Patients come in sometimes with a shopping bag full of paper, and there's no way I could go through all that. But if I scanned it, then I could extract the documents that had meaning, like but so I have to go through them by hand now. But that would be a valuable thing. And of course, faxes. Faxes, the images that come in on faxes of documents are often very poor quality. And then the silliest thing of all is faxing over VoIP. So it took forever for us to realize that our telephone vendor had foolishly set up our system so that all the fax lines went over VoIP. So you had terrible fax quality. And then when we brought the problem to them, they said, everyone knows you don't fax over VoIP. It's like, well, why do you tell me this? But I said I need 6 fax lines for the practice. What can you do? Yeah. So there's lots of good packages that do OCR. The trick of OCR is very fancy, and so we're not going to be talking about using Perl to do the OCR part itself, but just interfacing to a package that does it. There is, in fact, a CPAM module called Naive OCR, which does use Perl to try to build up characters. And it works, it's very slow. But it's a fascinating thing that in terms of converting images of characters to actual binary text representation of characters is a very hard problem. And it's amazing how well some of the software packages do. But corporate licenses for commercial packages are extremely expensive. They'll come in, they'll charge you like $5,000 a seat for 10 employees, 10 seats, people scanning. They all have proprietary APIs, so there's a built-in dependency. So if you're going to write code, you're going to be rewriting your code when the boss says we got to use a different package because the licensing is killing us. But they can be very highly accurate. They can be multilingual. They can be tolerant to different typefaces. They can handle a wide variety of inputs. And so some of them are very good. They can even recognize handwriting. The open source packages that have a commercial license, so I can develop my system where my plan is to create a system I can sell to other physicians that won't cost an arm and a leg. So some of the systems that are out there now, easily $50,000 a year to do, and that's way beyond what most doctors can afford now. Doctors used to make money, none of us make any money anymore. So that notion that we can afford something like this is crazy. And so a lot of the new, so what I'm trying to write is something which would be an open source package that with resaleable license. So the licenses we use, of course, the General Public License or the Apache License 2.0. And then the open source packages all have pretty flexible APIs or have CPAN module support. So they're relatively easy to use, or they just work from the command line, but they have very poor accuracy, unfortunately. So even the best packages have problems, which you'll see. And they can choke on different typefaces. So italic or serif font is very hard. I begged one of the big labs in town to please not use a serif font for their lab reports. And they said, you're the only person who's ever asked that, so no. And I said, I said, but don't you understand? I can't OCR your documents. And then finally I got somebody who said, oh, yeah, I'll change that for you. Who cares? And he fixed it, and all of a sudden all the reports were OCRable. It's amazing. And so we're going to focus on Linux environment because that's where I program, but there are, in fact, open source packages that run in Windows. So there are some Windows packages I'm aware of. So these are the 4 that are in common use for open source, and you can install these with a package manager in any Linux system. So the Gokr, which was a GNU project, medium speed but very inaccurate. OakRed is an old GNU project also, but it's fast, but it's very inaccurate. CanadianForm is interesting. It's a Russian system. I've known some amazing Russian programmers in the past who are just incredible. And so they're a company that was called Cognitive, which was doing OCR for commercial operations. They had a website. You could upload an image and it'll download a text for you. And the CanadianForm engine is quite good, and the accuracy is not bad. And then Tesseract is the king of the heap. So it's relatively slower than CanadianForm. It's got the best accuracy. Tesseract is a Google project now. It's and is available from Google's code.google.com, and it's installable as Tesseract OCR on any Linux platform. And it's probably the best. So here's a picture, one of my MRI reports. So this, I had to lie in the scanner for one of my research things, and there's an interesting ethical issue about that. So I have a number of employees. I'm the boss. I could say, yo, you have to go and put your head in the scanner, and they'll scan you, and then we'll get this project done. But I didn't feel I could really ask any of them to do that, because sometimes you find things in people's heads that are scary or something that you have to follow. So the only ethical thing was for me to volunteer to scan myself. So here's my report. It says I have a normal brain. I'm not sure if that's really true, but be that as it may. And then the document, so this document was obviously a text document, maybe some HTML. It was converted to a PDF as an image. Now it's an image. Probably internally, it's probably stored as a JPEG, which is, of course, lousy for storing text, but that's what it is. I've changed some of the things to protect the innocent. I've changed my date of birth. I made myself a little younger. I changed my session numbers and medical record number. I changed the company and the logo that actually produced the MRI. And so at the bottom, I changed the radiologist's name. A nice radiologist, and signed by the same nice radiologist. Yeah, who was nice enough to read my film. But everything else I left the same. So I thought that this would be a good document to see what happens when you run it through the open source OCR packages that are available.
See that your fourth ventricle is unremarkable.
Yeah, it's true.
You want to see, right?
I know. It's funny you say that, because unremarkable is sort of like code for normal, but it's the most hysterically passive-aggressive statement that the radiologists use all the time. They always say things like, "Oh, it's unremarkable," which in my mind means normal, but it sounds really funny. And I think, and then when patients read their reports, they get upset about that. They're like, "Well, does that mean he's dissing me?" He's like, "I don't care about your fourth ventricle." And I'm like, "No, I have to explain that means normal in crazy doctor speak." My dad's a radiologist, so it's very funny. So this is what it looks like with Gokr. It's a nightmare, obviously. You can't extract any kind of patient information. For date of birth, it did fairly well. Instead of being 45, it made me 15. I kind of like that. Nothing wrong with that, really. But you can't tell who I am. You know, my name is someplace in here or here. And so I think what's happened is that it's an engine that has a great deal of difficulty operating properly on this sort of damaged text that's been run through being converted into an image and going back. And so that's the output of Gokr. Then this is the output of OakRed. So OakRed does a little bit better. You can tell it's a diagnostic report. You still can't tell the patient's name, and it's very hard to extract other information like date of birth, which would be helpful. And you can't tell the ordering physician, and you certainly can't say anything else. I have a good brawl, though, apparently, whatever that is. I'm not sure what that is. Yeah, and so it's interesting how it does a better job for some things. It gets the formatting pretty good, which is interesting, but it still has a very tough time understanding actual text. And there's just little pieces in here that you could see are perhaps proper words. There's CuneiForm. So CuneiForm does a much better job. You can tell it's diagnostic imaging. You can tell the patient's last name is a little bit destroyed, but it got my first name properly, which is very interesting. So CanadianForm probably has some means of guessing from context whether it's a correct, whether it's got enough to say this probably is the word Stephen, not just the letters S-T-E-P-H-E-N. And so that makes it a better software product. And then it's got a lot more information, which is good, and a lot more stuff that looks like relatively good English, and you get some information out of it. So for the extraction phase for the practice, from the doctor's perspective, I want to be able to automatically route these things. I want to be able to get the information out and be able to say this document of the 1,000 documents that come in every day goes to this doctor for review, and do that without user intervention. And that is a hard problem, unfortunately, which is what motivated all the work I've been putting in. But this CanadianForm was almost top of the heap, and then one better is Tesseract. So Tesseract really shines. It did the very best job. It got the date of close to the date of service. It was actually 8:30, not 3:30. So it got a little bit better there. You can see this sort of common thing, that an M turns into an R followed by an N. So that's a common thing that I can correct in post-processing. And then I can recover my actual name, so that's good. And then information also about what type of document is this. It is an MRI. And so that can be matched up with the MRI order that is present on this patient, and then indicate that the order's been resulted. And that's an issue that happens in the SQL database, that the back end, of course, I like Postgres, that's why I use Postgres. But that's the SQL database back end, which depends on the information that we're going to extract from this in order to execute business logic, basically, that helps the practice workflow. So this Tesseract does the best. It's phenomenal. And it, for the most part, get a lot of information. It definitely runs a little slower. So I did benchmarks of the two most accurate engines. And so on the same document, which you have to convert documents to Windows BMP form for CuneiforM, and a peculiar version of BMP too. It has to be BMP3. There's only a certain type of BMP format that CuneiforM can handle. And as a sidebar, I like the time command. That's a very cool command in Linux, so you can time anything. And then these are just single runs, so if I was really doing real benchmarks, I would have run 1,000 times and averaged. But it looks like it's taking like 1.3 seconds roughly real time, 3.2 seconds for Tesseract for the same exact input, except the fact that you have to turn to a TIFF file instead. And then these also are enormous files. But then you get a little bit more answers from it. And so this is on my server, which runs at 4199 Bogo MIPS. It's a very powerful server. It's a 32-core AMD server. It's a dual AMD. Yeah, we're going to get 3.2 gigahertz, and low load too when I did that. So it's a big investment in time and effort. If you imagine 1,000 documents coming in, and it's occupying one of those 32 cores, 3 seconds per document. That's a lot, and so it's definitely CPU intensive to do this.
Did you ever get a chance to run your document $50,000 package?
No, I could. I have ReadIris installed on one of my Windows machines. I could do that. I found that those systems are actually pretty slow too. So I have there's a very nice scanner from Fujitsu, ScanSnap, which has built-in OCR and built-in PDF generation. So if you request OCR, then there's a phase after a sheet comes in where it scans it, and then it's going to extract words from it, and then annotates your PDF file with keywords that it extracted. It's not doing exactly the same thing, but it's making a searchable PDF. So a PDF that at least you could find words in it when you look at it. And that's a PDF I can extract text from. So the way my system works internally is it actually doesn't do OCR first. If it gets a PDF file, the first thing it does is it tries to extract text, because maybe it was a searchable PDF. Maybe there's some text that's meaningful that it could look at, and that would save the OCR phase. But that's definitely, if you do that, you would see probably much better result. Now, parallelism would be very helpful. I've got 32 cores, so why can't I use them? Because right now, these systems will run on just one core. and they'll do their work, but it's very linear. The application itself definitely is amenable to parallelism. And so there are some attempts to make parallel versions, but no open source code is available that does that. That'll distribute the analysis of a single page. So what I do is I treat each page in parallel. So if I've got a 15-page document, I distribute it out to 15 cores using a parallel fork manager, which is an excellent CPAN module, which can adapt to whatever hardware you have. It has automatic fallback to single core if you only have one core that can run on. But once you tell it how many cores to use, and there's a simple incantation to get the number of cores from the /proc hierarchy. You can then, once you know what that is, you can distribute things properly. And it does an amazing job, and it's very easy to convert any serial process can easily be converted to a parallel process by adding parallel fork manager. And it runs inside a for loop with a simple next statement. And it collects all the data. I'll try to post some code that shows how I do that. But in that case, I definitely, a PDF comes in 15 pages. I burst it into 15 separate files, operate on each file in parallel, and then concatenate all the output. And that's how you do OCR in parallel on the chief. And then GPU assistance would be very nice. So if you have a GPU, so big servers tend not to have GPUs unless you're going to do a lot of calculation with them. But if you have a GPU, are you going to mine Bitcoin, of course, of course. But the CUDA architecture from NVIDIA, Palkovich wrote 6 algorithms that he came up with and looked at what algorithms need in order to use GPU appropriately. With a GPU, you could speed up OCR pretty dramatically, and it makes a lot of sense, especially it's got a lot of shaders. So a lot of the code that we're using to play Call of Duty, a lot of the hardware, which is very important, of course, could also be used for this slightly more serious pursuit. And then Debnath, he wrote on SourceForge OCR for one of the scripts of India, Devanagari, using GPUs, and it runs wickedly fast. It's incredible, apparently. And so the instruction phase, what we want to do is we want to take the documents that are stored as images, and we can store them for human interpretation and communication. So the reports go into the patient's electronic chart. I can pull them up if I'm at home and someone calls and says, "Hey, what did my MRI show? I'm nervous about it." I could say, "Sure, I'll look it up," and then I can pull it up over the network and see it. Got my VPN and secure system. But in order to get the extraction phase, we got to do OCR. So that's the automated routing portion. And so what I need is the patient name, identify which patient it is. So I might need date of birth also, if it's a common name like John Smith. And procedure type, and then date of service, so I can tell when it got done, because that's a field in the database for one of the tables for physician orders. When did the order get executed? And that becomes important for how quickly are doctors responding to the results for patients, which of course is very important. So the point is the HR should route to the correct physician for review and indicate that order has been completed. And then an unresulted orders get reported. So I don't know if there's even a word, but I have a script called unresulted. It runs once every 3 days, and it checks all the orders across all the patients for each physician. And it sends out a report that's disturbing that you've got 80 people who have orders that are pending from 180 days ago. And so have results come in, do the patients actually get their orders done? Do they get to get their blood drawn, get their MRI done? And then you got to call people and say, "Hey, I know that you're busy, but your brain's important too. So please get your MRI. It's important." And so that's how we can generate that report. So the answer, of course, is regular expressions. This is how we're going to process the very noisy data that comes out of the OCR. And the output of one or more, we could do multiple OCR engines and then process them to extract the data. So based on the patient database table, so it's a huge table. Our practice now is over 15,000 people in it. So we've got this huge table where we can create from the table information which are regular expressions that contain what I call recognizers. So recognizers is a short regular expression, and we're going to chain them together in order to make a big regular expression. So when a recognizer fires, it's got to signal what it recognized. So the mechanism that regular expressions use in Perl are little extended regular expression, which the question mark brace contains data, which will be, when it's matched, will put the data in the scalar $hat$R. And so $hat$R is a scalar which is accessible inside code that's going to look at regular expressions. And so this is something similar to like $1 and $2 in capture expressions, but it's a special capture expression for this result. And then what's going to contain is the patient account number that for the patient recognized, and that's the primary key for the patient table. So if I recognize Flitman, Stephen, I'm going to say, oh, my account number in my system is 895. So it'll have 895 there, and it'll say that must be him. And then I'll have a hit that, okay, this document probably belongs to patient Stephen Flitman. Then you got to join these recognizers, and of course there are thousands of them, and we'll use the vertical bar to make a big RE. And then what happens is that internally, we have to rely on Perl's built-in optimizer. So there's optimizations that happen in the regular expression engine already for handling gigantic regular expressions that are, like 400,000 characters long. You can have a huge RE, and then it gets optimized because it gets precompiled. And that precompilation stage should say, what is happening there to improve things is there's some sorting going on, it's doing some length optimization, it knows when to bail on a particular expression, so it's getting smarter about it. So even though you've got 50,000 things that maybe a lot of them say Smith something, then it knows that as soon as the first letter is not Smith, it doesn't keep testing that. And as soon as the first letter is not Smith, if not S for Smith, then it knows not to keep testing all the other choices, all the other branches of the conditional that start with S also. So there's some pre-sorting going on which optimizes the, and so it actually runs very fast, thanks to the magic of Perl. So here's some recognizers. So I have a friend named Charlie Hand. He's not real, by the way, but he's a friend, and that's his account number. So this is what it would look like. So the \B, that's a regular expression marker which will match at a word boundary. And so we have to use that because what if there was some garbage and then hand, and then it wouldn't be clear if that was that, or if there was someone's name that contained the letter, the name, the word hand. So that would be or like Handy, Jack Handy. You don't want to match Jack Handy. And then, so you have that, and I've got $* question mark because we don't know what's going to intervene. Could be some spaces, could be garbage, some line noise that comes in from the OCR, and then Charlie. And then what we can do in the production version of this is a lot fancier. It also substitutes things, so it knows that, for example, an M can look like RN, or RN could be what was OCR'd, but what actually was a letter M. So it'll have brackets for that. So that's an example of that here. So I want to clutter this up and make it even more confusing. So here's an example of what the actual regular expression looks like. So instead of a 0, every 0 that might be in somebody's date of birth will be turned to, could be a 0, could be a letter O. Because there's no guarantee what the OCR engine is going to say. Tesseract might say this circle thing is a 0, might say it's an O. It doesn't know. It usually chooses O's. And so it'll print 1940 as 1940, and it'll be a capital letter O, or it could be in the lowercase letter O. But I do use, we're going to match case insensitive for all these things. So in the ultimate match, you'll see is that it's got the /I for case insensitive. And then we look at last name only and last name first name. So I have different sets of REs that I use. So we have the big one, which is last name first name or first name last name, because there's no guarantee what order they'll appear in. If there's a low frequency surname, and so there's a Perl database that you can, a module you can download that contains common names for different languages. It's in the lingua hierarchy. And so you can find out that, that this is a name that's not a common one. Well, then if you find it, bingo, you know that this document has to belong to that patient. So if the patient's name was something a little unusual, you could find it. And then date of birth, you'd like to distinguish people with the same name, because there are quite a few people with the same name. So it's not that uncommon. It doesn't sound like a name that would be that common. I have a number of people who have names that you'd think would be unique to them, but there are like 5 of them in Phoenix. And so that makes it a little hard. And then year of birth, of course. So then this is how I'm dealing with the fact that there's multiple people. So I'm passing an array of patient account numbers instead of a single account number. So in this expression, you're allowed to put brackets, and you could put a comma-separated expression, and so that's going to be an array reference, which is being passed as a scalar. It doesn't look like it'll let you send an actual array. You got to do an array reference. So that's why I'm using the square brackets. But then, so there's lots of people who were born in the same year, so you'll have an enormous list of account numbers, but it's, another thing that will be good. Then we do lots of research at our company, and the research, people all get an ID number when they're in a research protocol. So we got to catch their research number. So if somebody was, their research number was A010111, then that would be something we'd want to capture on a document that came from a research firm, for example. And then because that's such a unique identifier, I put the number twice, and that goes into my scoring system for whether or not a particular document really fits a particular patient. And so these all fit into the scoring system. So then we have to basically get a list of arrays and then try to figure out what the rank is. And if somebody bubbles to the top, they've got multiple hits. You hit the name, you hit the date of birth, you hit a research number or something extra, then you know for a fact that this must be this particular individual, and then your confidence is much higher. And then the system will report that that's what the system document was recognized. And it's pretty accurate. I'm always surprised when it gets it right. A lot of times, if it's really garbage stuff, you don't get it though. So this is the match subroutine. So the pre-compilation step is that we create the RE, so all the recognizers, which could be an enormous number, could be 20,000 little expressions. We're going to join them all, and we pre-sort them. This seems to help. And I proved this to myself kind of empirically with benchmarks. If the Perl optimizer works the way it's advertised, it shouldn't be necessary to sort by length, but I do anyway because it seems to be beneficial. And it's something which I probably, having done that big upgrade, I probably should repeat the benchmark and see if this is still true. Because this step, I could probably maybe save 15 microseconds or something if I got rid of the sort there. And then we pre-compile by putting it in the subroutine. So you have to say use RE eval, or won't let you use $.hat_r. It doesn't like that expression unless you use that. So that's turning on the ability to use evaluations inside of your regular expressions. And so that's the question mark with the curly braces. And then, of course, it's going to be global, we're going to be case insensitive, and we're going to treat the output as a huge single line. And then that's what seems to be very necessary, because maybe there'll be line breaks in there, and then data will be mixed up because of the formatting. And then every time a match occurs, it'll push it in here, and so what we're going to get in here are scalars or array references. And then those will be what are returned. And then because the whole thing is attached to a scalar deferred function called match, process in other languages, then we can call it like this and get it out. And then because it has been done once, we can save it, and the process can run like a daemon, can run over and over, and you save a lot of the pre-compilation step. And it only has to recreate the huge regular expression if there's been a change to the database. So if someone registered a new patient, or if someone changed, so all those fields have triggers attached to it that set up a signal called regen RE that causes the OCR subsystem to say, oh, I got to regenerate the whole regular expression system because one of the people in the office changed the patient's name. Lady got married, got to change her last name, and that because documents coming in may reflect her new last name. I have an AKA field to preserve a person's maiden name, but for exactly that situation. But it's fascinating writing this code while dealing with real world situations because you have to keep adapting and keep thinking about how real documents are coming in and how it works. I try hard not to make changes to the production server, but every now and then I'll see something that's not working, and it's like, I gotta fix that. And I'll pour it over to the production server from the development server. And then this is how we combine the regular expressions information. This is called get intersections. So I had to write some fairly fancy code that would basically see if you get a list of lists, and then you get a hash of scores, and the hash will contain who's ranked where. And you got to figure out what the rankings are. So there's like a scoring system. So if I had 1, 2, and 3 were one result from one match, and 3, 4, 5 from another match, I have to find the intersection. And so that's 3, so that's the 3, and it appeared twice. And so that's a score of 2 for that account number 3. So it goes through, you do the mapping, we sort those, and then we want to get only ones that are seen more than once, because anything that's seen once, but I'm using multiple matching system, must be an error. It's just not good enough. So we throw out anything that was just matched once. Just a name and not a date of birth is not good enough, unless we have nothing. If we have nothing that comes out, then it'll accept that as maybe the only best result. And frequently it's wrong. So I try to make it match on two points. And then it does some fancy sorting, and then it comes out with what the best are. And then that's what gets mapped. And so if there are only 3 that come out, that's good. So a 3-way tie is okay. If there's a 2-way tie, it's okay. If a single person is identified, that's perfect. And it'll report John Smith or Jane Smith if it can't tell, so that'd be a 2-way tie. Or it'll give you a third one. But it won't do a 4-way tie. It'll just choke and say, oh, nothing matches because it's obviously garbage. They're not getting anything real out. And then that's how we call it to get the scores out. And then the scores array, what we're able to do is get the information. So the highest score wins, basically. So it maps accounts to score, so you can get the highest scored key for the account, which will be essentially the document. And then, so let's say, and these come to the doctors as email, and the email subject says, lab report or something like that. And then when the doctor hits the OCR button, if they're looking at it there, or this happens automatically if I turn on automatic OCR processing, then the email subject line gets changed. And then in the database, it'll show that this email now is attached to that particular patient. And then there's a field in each email in the system for which chart number it belongs to. But so we allow 2-way and 3-way ties, and then we would rename like Smith J or Weiss D to show that a human must distinguish. And that still saves time. See, otherwise it's unrecognized. So if it's unrecognized, then you get a lab report, you gotta scroll down, you gotta look at it and say, oh, it belongs to John Smith, because people do this really fast. But if you have 500 documents to look at, that gets pretty bad. And the doctors aren't always computer savvy, and they don't really want to deal with that. So that's why we have to do this sort of system to try to improve the throughput. And we'll never get to the point where it's automatic routing if it's still doing lots of 2-way, 3-way ties, because you can't route it to a particular person if you don't know who it really belongs to. It could be either of these guys. And it'll drive the doctors really crazy if you route to 2 doctors. They won't like that because they'll be fighting over the document. You can't have that. Yeah, so I think, OCR is really only the first step. What we do automatically, where you can just look at something and instantly know who it belongs to, is a lot of effort. It's amazing how difficult a problem that is to do digitally. There are some interesting things out there which may eventually rival or surpass the human ability. So neural network implementation, Cahonen wrote actually quite a long time ago now about bidirectional associative memories. Some of his papers date back to the 80s. And these are basically a neural network system where you train the network on lots and lots of, this would be patient names and their images in various fonts. And then you'd be able to rapidly present an image, a pixel array to the network, and the network would do its mathematical thing like a brain, and would pump out what the association is with fair confidence. And it can deal with degraded input. It's pretty good if letters are missing, if the OCR output, for example, is garbage and my name's all mangled. It might still pop out with my name. A lot of face recognition systems are working on this. And then there's quantum systems which are coming. Suzanne Gildert is this amazing physicist. She's a physicist and a painter. She paints beautiful pictures. But she works at a company that's working on quantum hardware, and they've got called D-Wave. They've got the first quantum coprocessor. And their adiabatic algorithm is a system which relaxes down like an optimization problem, and it can easily come up with solutions to very difficult problems. And so OCR and automatic recognition is one of them. So while right now, like they want $3 million for their system, I'm sure. Eventually, because it's just silicon, eventually quantum coprocessors may become commodities, just like like GPU, and we may have QPUs, I guess. That would be very cool, because there's some hardware things that would run much faster if you used quantum algorithms for them. So Shor's algorithm, for example, is a search algorithm that can run in like order 1 time, or log n time, I believe. Better than many other searches, and much better than linear search for sure. And it could do so very rapidly, kind of like hashing, but it's like even better than just hashing. So I'll open it up to questions.
Do you have like a methodology to deal with the log files that are unrecognized from the OCR?
You bet. So what happens is that many documents don't get OCR'd. So when I turn on automatic routing, which is always dicey because the system is still pretty fragile, when it happens, I'd say that recognizes maybe 8% of documents, and 20% that don't get routed to me. And then they end up in my inbox, and I have to go through them and be the mechanical Turk and manually route them, which is not terrible, but I could imagine how that could be made better if the algorithm was better. And so if I could afford better, so let's say if I made this modular enough with Perl that I could interface it, if someone had the money that they wanted to buy a commercial product for OCR that would do a better job than Tesseract, I should be able to make my system interface with that, and then the text extraction part would be very fast, because it would be obvious that this belongs to this particular person. Yeah. Go ahead.
I got 2 questions. I did some work for a number of years on just exactly what you're doing with production OCR system.
Yeah.
And what we found was each step of the way the quality was really important, especially the first step.
Enormous.
Was the scanning part.
Oh, yeah.
And so if we got a really good scan, and we scan it to a really good quality document, but of course not too high quality, or it takes forever, to store it and everything. And then if we got the brightness tweaked properly, and the contrast and that kind of thing, the improvements in quality was dramatic.
It's very remarkable.
And then the last thing, the second question, I was just wondering what your experience, if you had a similar experience? Like
Completely, yeah,
Oh, okay.
because I'm dealing with degraded input already, because I'm dealing with faxes.
Right.
So that they got dots. I despeckle them. I use image magic, and I have to resample them to a much bigger canvas, so that I'm blowing them up. So I'm giving the OCR engine more to work with, and I'm despeckling them to get rid of all the dots, and then I get something cleaner, and it seems to recognize better on bigger input. So the memory requirements are enormous, but you have to do it, and I discard the
We were doing
fixed
phone
ones.
books and sometimes even link pages, and it was nasty. But
That's probably hard.
fax would really be tough.
Fax is tough.
Now, the other thing we noticed was if things got jogged one way or another,
Oh, you got to
good
deskew.
luck. Yeah.
Yeah, so I have automatic deskewing. Yeah, and then also the system, if it gets garbage, there's no match at all. It automatically inverts the whole thing and goes through OCR again, because maybe it was upside down. And guess what? That happens a lot. I've even had things come in 90 degrees rotated. And it's crazy. There's someone out there who, for some reason, their lab reports are always in landscape mode and always get faxed in portrait mode. So so OCR always fails, and I'm like, oh, this is annoying.
So my second question is, in the end, there was always a certain percentage or amount
Yeah.
of source that you just had to hire a bunch of typists to just get it into the database or something.
That's right.
Is that what you end up doing with
Yeah.
some of it?
Yeah, so the manual phase basically is, it looks like an email. You have to, my emails all come up in the system with in the web browser. And so it's like webmail, or like Gmail. But the subject line is editable. So you have to retype the subject line, then you hit the chart button. And if you typed in the subject line, Flitman, Stephen dash MRI, it would go to my chart, Flitman Stephen Flitman, and as in the MRI section of the chart as a report that belongs there.
So do you have to deal with the final errors, or do
Sure.
you, so
I can train the staff to do that. It's not hard to do, but the problem is that unless the staff have all been in medical school, it's a big problem because they can't always identify what they're looking at.
right.
And there's lots of gotchas. So we have a hospital department that puts the word electroencephalogram on the top of everything because everyone calls that the EEG department. But they do other tests there. They do visual evoked potentials, which are for the eyes. And it says electroencephalogram on top. So all of those get routed to me as EEGs when they're not EEGs. And I have to actually physically look at the document and say, look, that's a VEP, not an EEG. So that drives me a little crazy. But if the system also has a regular expression to note what kind of report it is, and it looks at keywords like magnetic and for MRI, or unremarkable. It uses unremarkable because only radiologists say that, so that's a real clue. But things like that are necessary in order to distinguish those documents. If the OCR part fails, now I'm relying on a human being to do it again, and it adds up in time. I got to pay my workers.
Now, lastly, obviously, there's going to be some amount of errors and mistakes that just are unavoidable.
All the time.
So, unfortunately, in this case, in the case I worked on, it just meant we had less in our database.
Yeah.
But in your case, it could be
It's
diagnosis or.
it's mission critical. Yeah, so that's the thing. So no document ever gets read without having been seen by a pair of eyes first. And then the way the system works right now is it has to be a physician who decides finally. So as far as I can tell, it's a great point, and something that keeps me up at nights. No report has come in that has been filed away sight unseen. That's definitely the problem that plagues a lot of systems that are commercially available. There's a huge issue with that. And that's definitely exactly where doctors get into trouble, and so to be very cautious. It's a very good point.
Interesting to me because it
Oh, yeah.
just reminded me of my first job out of college working on a fingerprint system. And it was the same thing with latent prints. Always a person made the call. The system would dump out the potentials, but there always had to be a person.
There has to
An
be.
experienced, licensed person that made the call.
I think it has to be, and that's the thing is at the end of the day you're dealing with people's lives. It's important, and so I think that's that mission critical aspect that there has to be ways to minimize the cost of healthcare. I'm all for that, and I believe in technology. I believe in computers helping things. I haven't seen a tremendous amount of efficiency increases that were kind of promised, by folks who wanted to promise things like that, but. I believe that someday it's going to happen where we'll be able to maybe transition to a paperless system and maybe be able to say that we really have a system in which documents come in, they get reviewed, and care happens in a more efficient manner. And I think it's going to happen, and this is a piece of the puzzle. But these are enormously good points that you've made. It's a big issue. You had a question, sir?
I don't know if it was a question as much as I was just thinking about, what is the system that the banks use for the ATM deposit?
Yeah.
And then I thought, well, the problem is probably a subset of what you're doing, because at the end of the day, they can use the lines to fix the skewing, and they're really only looking for numbers.
Right. There's a lot of.
It does a good job at handwriting.
It does a very good job. It's fascinating. There's some I have some questions about that. I don't know exactly how things work in that industry. I imagine that security is paramount, but there's this one issue about whether they're doing good recognition of signatures and comparing signatures to signature cards, whether really a human being is doing that or is that really computerized? And because I've had checks go through with no signature on it, or I've had the wrong signature. So I had a long time. This is quite many years ago, but a checkbook was stolen when I was in college, and so someone was using my checks and signing their name. They were a little silly. They got caught, hopefully went to jail, but I got my checkbook back. But it was so people had obviously accepted some of those checks, and some of them had been processed by my bank. So at least at that time, which is more years ago than I want to mention, they probably did not have good verification there. And so you think that the ATM systems now probably are using some type of handwriting recognition in order to make that connection for deposit? It has to be, yeah. When you make an ATM deposit, though, you are including a deposit slip, which has has RCO codes.
Put your
No,
check in, and then
fascinating.
all you
Yeah,
have to do
just-
is
it-
verify the amount that it thinks.
Yeah,
that
it
you put
thinks-
in.
Because you're logged in as you.
Yeah.
Yeah,
It thinks you have a particular amount,
yeah.
and then it says, is this right? And you say accept or deny or
It doesn't show.
edit or whatever, but
Yeah.
yeah.
Remarkable. So it knows it's you verified identity because you used your PIN.
Right,
It's not so the routing part is handled,
right.
but there's a question there about how does it know when you say, yeah, this is a check for $50,000. Yeah, you put a $5 check. Yeah, how's it going to make that distinction? At some point, a human being has got to verify that, and I'm sure it's always true in the financial industry. But that's just fascinating. Yeah. Yeah. Yes.
It makes sense that you would be able to send this information over email, but I'm surprised that you can send it over fax. Wouldn't that be just as interceptable?
It's a fascinating thing. Fax is considered, from a legal perspective, to be more secure because it's point to point. You need a search warrant to tap it. You know, allegedly. A lot of debate there, obviously. If you send it over VoIP, it's still sent in lots of packets, and it's really hard to reconstruct either anything out of VoIP packets.
And it's still lousy quality.
And it's very lousy quality, exactly. But if you send it over analog lines, it's pretty secure. It's felt to be better than email, because with email, I can set up a server in promiscuous mode, mail server, and say I'm a relay host, and I could spy on all the documents that get relayed through. So that wouldn't be good, because that's what the bad guys do, to steal credit card numbers and find people to go after for identity theft.
Couldn't
Yeah.
you do like a SSH type tunnel?
Yeah, I
point to
could.
Point, through, what was it, SSL, Doug?
Oh,
Yeah,
like
sure.
Stunnel or S-Tunnel, or I don't know.
S-Tunnel.
how it's pronounced, yeah.
Yeah, I've never.
SSL.
It's definitely, yeah, you can tunnel things through SSH. There is a protocol called HL7 for getting blood work and get laboratory data in HL7. HL7, you have to set up a port that will accept HL7 transmissions. And originally they were all plain text. So anybody who had a packet analyzer, of course, they'd Wireshark, they could still see, they could see information that's supposed to be hidden. But now they're encrypted. And so you can definitely get encrypted HL7. And so that's one input which would then solve this problem, because it would bypass all of this. All I would need is just an HL7 stream. The problem is that not every vendor in town wants to give you HL7 access. And some of them want to charge you for it. They're like, oh, well, you're like an insurance company. You must have a lot of money, so we want you to pay for it. And so that's a big problem. So I envision that I'll have, I want a clinic that might cater to people who don't have any money to pay for care. And they're operating mostly on donations and volunteering to be able to use our system.
What
Yeah.
about medical encoding? Because like when you file for insurance, there's a code for everything.
That's
like
right.
You issued someone a Band-Aid, you put it down there, the particular diagnosis,
It codes for everything.
Needle that's used for a blood draw.
You bet.
Couldn't those codes be transmitted if you have a table that says, okay, I recognize these codes, then my diagnosis is this, or what, it would be a lot more, reliable in that sense.
If only there was.
Data from a picture.
That's right. I mean, that makes a lot of sense. But it still speaks to the problem of how the data gets to you. If the transport is over fax, okay, it's felt to be less eavesdroppable. It would be nice if they included CPT codes. So the CPT code for that MRI was 70553. So 70553, if it appeared anywhere on there, I could search for CPT code. That's the insurance company's notion of what an MRI brain with and without contrast is. And if I found that, I'd say, well, this document is definitely an MRI because it had the MRI CPT code on it. So that'd be great if it would have that. There's huge debate now that they want to delay ICD-10, which is the next generation of diagnosis codes. We're all using ICD-9 codes, which aren't as specific. And so I think that those sort of things are going to appear in medical documents more and more. Right now, they're mostly only see them billing, and so the system doesn't deal with billing. That's a whole other if this is like a universe of trouble, that's another universe in the multiverse of medical applications.
That would be associated with the results, and the person performing the exam or whatever would say, okay, well, I'm definitely billing for this, but I also need to forward this information back to the requesting physician and send those codes along with it. Yeah, I mean, to me,
That makes tremendously good sense. At this time, this major vendor in the Valley does not produce reports that have the CPT code on them, but that is the code that you're talking about. So there was a code somewhere that when that was the order that caused this MRI exam to be done. The CPT code was on the order, and the diagnosis code for research, V70.7, was on there too, but it doesn't appear on their output. And so you'd have to somehow compel vendors to include that in their result faxes or result documents. And right now, there's no law that says they have to do that, so it's a mishmash. Some will, some won't. You almost never see it on lab work. You almost never see it on MRI reports or things like that. You'll occasionally see it in doctor reports. Like when if I send somebody to a surgeon to take out something that was troubling the patient, they will send me back an op report. Well, I did the surgery, and this is all the things I did. And at the end will be some surgical billing codes and things like that, and maybe a diagnosis code, and that's helpful. But it would be nice if they started doing that more. And I think that eventually there'll be some mandate to do that because it makes so much sense. And I know that I'm not the only person dealing with this situation. There must be many people who are trying to create software that'll help their practices run more smoothly or writing for that particular niche. But it's a really big problem. Go ahead.
It seems like with the government getting involved and how its love for bureaucracy, that it would start to institute some kind of standards for the paperwork documents themselves. Like
It's
if
coming.
you do a tax document, you know what a 1040 form is.
Mm-hmm.
And you could set up your optical character recognition to look for blocks, and then within those blocks do the OCR on the blocks instead of the whole document.
I think that there's certainly movement afoot to do something along those lines, because right now I'm going through the validation stage of our software. So if I can get validated, then other doctors can purchase it. They can purchase it, but they don't get any benefit. They don't get what's called meaningful use if I don't have a meaningful use stamp on my software. So that's going to cost me $26,000. So just to go through testing, someone's going to remote test all my software, and then hopefully it'll pass, and then they give me the stamp. Those criteria are now, there's 2011 criteria, there's 2014 criteria for EHRs. And so it's coming that they're going to start building towards some kind of common format. But right now, there's huge debate, like what will be the underlying format of that? Are you going to allow people to use XML? Are you going to, because some data doesn't fit well in XML, like binary data, so are you going to have some sort of hybrid thing? There's no standards because no one can agree on them yet, but it's coming. I see some medical systems are outputting stuff like EMG systems are dumping XML. So I think XML people are thinking about as a good, as a decent system for representing some of these things. And then XML, there are lots of great tools for parsing it. So I mean, that would be good. Or YAML, that'd be nice if it was YAML, that'd be cool. JSON, of course. Yeah, but I think that at some point there's going to be more standardization. There isn't right now. There's also this entirely separate thing, which has nothing to do with what we're talking about really, except to say that there's a lot of recalcitrance in the field of medicine to standardize too many things because there's a fear of things turning into cookbook medicine. And you know that you don't really need a doctor anymore. You know, you could just stick your arm in a machine and it'll tell you what's wrong with you, and some pills will pop out. And I think maybe that's what we're headed towards. If only we knew that much about people and why they get sick, which we don't really know. Because the reality is, you need a doctor because things are complicated. That there's no algorithm that'll that'll make everybody well. And so I think there's resistance there to that kind of standardization. Yeah, I definitely see that.
Yeah, Marty's been saying for years that they're eventually going to replace programmers. They haven't done that yet.
Yeah,
Doctors are way after us, so.
it's a funny thing, but I have people who come to see me who have seen 8 other people, and they said, and then I tell them, well, this is what's wrong with you, and give them the diagnosis 5 minutes after I meet them, and they say, well, how do you know? And it's like, are you any smarter than them? And I say, no, it's just that after all this time, it's become more obvious what's wrong, and that's the sad truth with a lot of diseases. Yeah, this is like Parkinson's are like that you can see 8 people when it's early and no one can really tell what's going on. There's something's a little wrong, and then when it's obvious, it's obvious. The moment you lay eyes on somebody that they have Parkinson's, if it's advanced enough. And so that's a big issue that the early phases of a lot of diseases there's no algorithm to detect them. That's what makes it difficult. But I think you're right. Yeah, I've seen the efforts to like code compilers and things like that to replace programmers. That doesn't work. It's funny. Well, thank you very much.